Roster form introduction. In mathematics, a set is a well-defined collection of distinct objects. What this means is, a set is simply a group of things. These things can be numbers, letters, or even other sets. The important part is that the group is well-defined, meaning it's clear exactly what belongs in the group, and distinct means that each item in the group is unique. We don't have any repeats. Representing these sets in a clear and concise manner is crucial. Think about it. If you just randomly wrote down a bunch of items, it would be hard for anyone else to understand what group you're talking about. So, mathematicians have developed ways to write sets down neatly. One of the most common and straightforward methods for representing sets is the roster form. This is what we're going to focus on in this tutorial. It's a really useful way to show what's inside a set. This tutorial will guide you through understanding and utilizing the roster form effectively. Over the next few slides, we'll break down exactly what roster form is, how to create it, look at some examples, and even point out common mistakes to avoid. By the end, you'll be able to confidently represent sets using this method. Let's move on to the next slide to dive a little deeper into what roster form actually looks like. So let's begin our discussion on representing sets. What is roster form? So let's move on to understanding exactly what roster form is. As we discussed on the previous slide, roster form is one of the ways we can write out sets. This slide tells us that the roster form, and you might also hear it called the listing method, is simply listing all the individual items or elements that belong to a set. And here's the key: we enclose all of those elements within curly braces. Think of curly braces as special brackets that tell everyone, hey, this is a set. So we write an opening curly brace, then list everything inside, and then close it with another curly brace. Next, each of those elements, each of those items in the set, is separated by a comma. Just like in a regular list, commas help us distinguish between each individual item. Now, this method works best. It's particularly useful when the set has a finite number of elements. What does finite mean? It simply means there's a limited, countable number of items in the set. We can actually list them all out without going on forever. We'll see in later tutorials that there are other ways to represent sets when they have an infinite number of elements. But for now, we're focusing on sets where we can clearly list everything out. In the next few slides, we'll work through some examples to really solidify this concept, so you'll be able to confidently represent any set using roster form. Steps to represent a set in roster form. Let's move on to slide 3. This slide outlines the steps to represent any set using the roster form, which, as we discussed, is simply listing out all the elements within curly braces. Step 1. Identify the elements. This is where you first need to clearly determine exactly what objects or items belong to the set you're working with. Think of it as making a complete list in your head before you start writing anything down. Step 2. List the elements. Once you've identified everything that belongs in the set, you write each of those items down inside curly braces. These curly braces are crucial. They tell everyone that you're defining a set. So, if your set contained the numbers 1, 2, and 3, you'd start with an opening curly brace, then list the elements, and then close it with another curly brace. Step 3. Separate with commas. Now, to keep everything clear and organized, you need to separate each element in your list with a comma. This makes it easy to distinguish between the individual items within the set. Step 4. Avoid repetition. This is a really important rule about sets. Sets only contain distinct objects. That means you can't list the same element more than once. If you try to, it's not a valid set representation. So, if you accidentally wrote the number 2 twice, you'd need to remove one of them. Step 5. Order doesn't matter. Finally, remember that the order in which you list the elements doesn't change the set itself. A set containing 1, 2, and 3 is exactly the same as a set containing 3, 1, and 2. We can illustrate this by saying that the set 1, 2, 3 is the same as the set 3, 1, 2. Sets are about membership, not about the arrangement of their elements. Keep these 5 steps in mind, and you'll be able to confidently represent any finite set using the roster form. In the following slides, we'll work through some examples to solidify your understanding. Examples: set of the first three positive even numbers. First, let's identify the elements. What are the first three positive even numbers? Well, 2, 4, and 6, right? These are the numbers we need to include in our set. Next, list the elements. Now, we take those numbers and enclose them within curly braces. Remember, the curly braces are essential. They tell us we're defining a set. Then, separate with commas. We need to separate each of these numbers with a comma. This just makes the set clear and easy to read. Therefore, putting it all together, the set in roster form is curly brace 2, 4, 6, and then close the curly brace. So we write it as 2, 4, 6. Let's move on to our first example of representing a set in roster form. As we discussed in the previous slides, roster form is simply listing all the elements of a set inside curly braces. This is a very straightforward example, but it illustrates the basic principle of roster form. We'll see a few more examples on the following slides, including how to represent an empty set to solidify your understanding. Remember, the key is to clearly identify the elements and then list them correctly within those curly braces. Examples: set of vowels in the English alphabet. First, identify the elements. We need to determine what the vowels are. As you know, the vowels in the English alphabet are a, E, I, O, and U. Next, list the elements. We take those vowels and enclose them within curly braces. So, we're going to start and end with an opening and closing curly brace. Then, separate with commas. To clearly distinguish between each vowel, we separate them using commas. Therefore, when we put it all together, the set in roster form is curly brace, a comma, E, comma, I, comma, O, comma, U, and then a closing curly brace. We write this as a E, I, O, U. Let's move on to another example of representing a set in roster form. As we discussed in the previous slides, roster form is simply listing all the elements of a set inside curly braces. Remember, as we saw earlier, the order doesn't actually matter. E, I, O, U would represent the exact same set. What does matter is that each vowel appears only once. We don't want any repetitions. In the next slide, we'll look at an example involving prime numbers, so you can see how this applies to numbers as well as letters. Examples: set of prime numbers less than 10. Let's move on to another example of representing a set in roster form. As we've discussed in the previous slides, remember that roster form simply means listing all the elements of a set inside curly braces. Now, this slide asks us to represent the set of prime numbers less than 10. First, let's identify the elements. What are the prime numbers less than 10? A prime number, just as a reminder, is a whole number greater than one that is only divisible by 1 and itself. So thinking about that, the prime numbers less than 10 are 2, 3, 5, and 7. Next, list the elements. We now take those numbers and enclose them within curly braces. So, we'll start with an opening curly brace and then list our numbers. Then, separate with commas. Remember, each element in the roster form needs to be separated by a comma. Therefore, the set in roster form is curly brace 2, 3, 5, 7, and then a closing curly brace. We write this as 2, 3, 5, 7. This is a complete and correct representation of the set of prime numbers less than 10 in roster form. In the next slide, we'll look at a slightly different type of set, an empty set, so keep that in mind as we move forward. Examples: an empty set. Let's move on to a slightly different concept. As we've been learning about representing sets using roster form, listing out all the elements, sometimes we encounter a situation where a set has absolutely nothing in it. That's perfectly valid. A set doesn't have to contain anything. When a set contains no elements at all, we call it an empty set. Now there are two ways to denote or represent an empty set. The first is using a special symbol. It looks like a slightly slanted capital O, and we pronounce it as empty set. The second way, which is equally correct, is simply using curly braces with nothing inside them. So, just an open and close curly brace. both of these notations mean the exact same thing, a set with no members. Let's look at an example to make this concrete. Consider the set of all even prime numbers greater than 2. Remember, a prime number is a whole number greater than one that's only divisible by 1 and itself, and an even number is any whole number divisible by 2. Think about it. The first few prime numbers are 2, 3, 5, 7, and so on. The only even prime number is 2. So, if we're looking for even prime numbers greater than 2, there aren't any. Therefore, the set of all even prime numbers greater than 2 is an empty set, and we can represent it as either empty set or with empty curly braces. This is an important concept to grasp, as it shows that sets can be quite flexible. They can contain many elements, a few elements, or even no elements at all. In the next slide, we'll recap everything we've learned and also discuss some common mistakes to avoid, so you can confidently work with roster form. Key takeaways. Let's recap everything we've learned about roster form with these key takeaways. Roster form is a simple and direct way to represent sets by listing their elements. Essentially, as we've practiced, it's just writing out what's in the set, clearly and neatly, inside those curly braces. Remember, this is one of the most straightforward ways to define a set. Elements within a set are distinct, meaning no repetitions. This is super important. A set doesn't like duplicates. If you find yourself writing the same item twice, you only include it once. Think of it like making a guest list. You wouldn't write the same person's name multiple times, right? The order of elements in roster form does not matter. This is a key property of sets. Whether you write 1, 2, 3, or 3, 1, 2, it represents the same set. Sets are about membership, not the arrangement of the members. An empty set contains no elements and is represented by the symbol which looks like a capital O with a slash through it, or simply using empty curly braces. We saw an example of this earlier, a set with nothing in it. The symbol, often read as the empty set, or just the null set, is a useful way to denote this. You can also just write it as two curly braces right next to each other with nothing inside, which is also perfectly acceptable. Now that we've solidified these key points, let's move on to look at some common mistakes students make when working with roster form. Being aware of these will help you avoid them in your own work. Common mistakes. A very frequent error is accidentally including the same item more than once when you're listing the elements of a set. Remember, from our earlier discussion, a set, by definition, contains distinct objects. That means each element must be unique. So if you're listing the set of even numbers, for example, you wouldn't write something like 2, 2, 4, 6. The 2 appears twice, and that's incorrect. The correct representation would be 2, 4, 6. This one seems simple, but it's surprisingly common. You absolutely must use curly braces, and we say curly braces to enclose all the elements of your set. If you forget to include them, you haven't properly defined a set in roster form. For instance, writing 2, 4, 6 isn't a set, it's just a list of numbers. The correct way is 2, 4, 6. This is a more conceptual mistake. Roster form represents a set, and a key characteristic of a set is that the order of its elements doesn't matter. We saw earlier that 1, 2, 3 is the same set as 3, 1, 2. However, don't confuse this with things like ordered lists or sequences. In those cases, the order is crucial. Think about a code or a password. 123 is different from 321. Sets aren't concerned with order, but ordered lists definitely are. Let's move on to the final slide, which highlights some common mistakes students make when working with roster form. This is really important, so pay close attention. So, keep these common pitfalls in mind as you practice, and you'll be well on your way to mastering roster form. This concludes our tutorial on roster form. I hope this was helpful, and feel free to review the slides if you need a refresher.